Hey everybody, so in today's video we're going to be talking about circuit analysis. So this is the third video in a series of videos in which I was talking about distribution switching. So now in this part, circuit analysis, we are actually taking a look at the circuits that are being utilized, and the whole purpose of circuit analysis is, number one, we need to make sure that we are working on the correct circuits, first of all. Second of all, we need to make sure that the areas that need to be de-energized for the crews to do the work are properly de-energized. Third, we need to ensure in this part of circuit analysis that we are utilizing the correct protective devices for isolation purposes. Fourth, when we are doing circuit analysis, we need to ensure that the circuits that do need to be switched out, they do get switched out correctly. And number five, to make sure that when we are switching circuits out, that we do so correctly, and we also need to make sure that we have the sufficient capacity to be able to do so properly without damaging equipment, without burning anything down. So in the first part, determining exactly what circuits need to be worked on, that is answered by the previous video in which we talked about the questions. That is where the set of questions come in, right? The set of questions tells us the nature of work, and more importantly, the actual location where the crews are going to be working at. Based on that location, now we utilize that information or tools where these guys are going to be working on, what circuits are they going to be working on particularly, and what other circuits are around them, to make sure that we do not miss anything, we do not leave anything energized that does not need to be de-energized for the safety of the crew. So using the exact location where the crews are going to be working on, we're going to be working two directions. First, we're going to be working our way backwards along that circuit from the point of work where the crews are going to be at. We're going to work our way backwards towards the source in order to determine all the protective devices that need to be utilized and opened up, isolated, whatever you want to call it, going upstream. The second direction we're going to be working is downstream, if necessary. From there, we're going to try to figure out if there's any other devices, protective devices, that need to be utilized in order to help isolate the area of work where the crews are going to be working on. Then you make a brief list of those devices you're going to be utilizing, and from there, compare it to the original request. This is going to be the first check you're going to make to ensure that the work that you're doing, to ensure that the plan distribution that you are writing is correct, and that you're not going to be wasting your time further down the road. So once you've done your work of analyzing your clearance points, not only upstream but also downstream, then you have to take a step back. Take a look at the area that you've already planning on clearing, utilizing clearance points, and ask yourself this question: is the area that you're isolating the correct area? Also, second of all, you have to ask yourself, is the area you're going to be de-energizing the correct area you're going to be de-energizing? And are you going to be leaving any other customers de-energized that are not supposed to be de-energized? And if they are, let's just say for an example, you do have additional customers that you're going to be leaving out, you're going to be de-energizing because of these clearance points, is there any way to actually backfeed them? Is there any way to switch them out so that way they could be restored and or possibly avoid being out altogether? So now as a second step, in the case that you do need to transfer distribution load out, you have to figure out what your options are and what choices you have available to you in order to be able to transfer that distribution load out. So what I like to do is analyze the circuit. And what I like to do is first run it out completely, right? So what I like to do is I'd like to take the circuit from the beginning, from the source, and trace it all out. And I do this in order to figure out how it actually runs, and to also be able to figure out the different branches that it may have, to try to be able to figure out the complete list of all the available devices that are on that circuit that I can use in order to transfer distribution load out, not only from the beginning of the circuit, but also towards the tail end of the circuit, but most importantly, around the area where the crews are going to be working out, so that regardless of what part of the circuit needs to be transferred out, as part of this planned distribution switching, I know exactly where the switchable devices are located at along that circuit that I can then use as my options as my choices. In order to make it as simple as possible, what I recommend and suggest is that you begin to draw a simple diagram that shows the breaker in a linear format along with its different switches along the way. Now, what I'm showing here is an example is just a simple circuit that has 4 different switches. Now, of course, a circuit that you may be dealing with may have more, may have less, but regardless of how many devices it actually has, in my opinion, drawing this simple linear diagram of how the circuit and where the different devices are will help to make things a whole lot easier when it comes to visualizing your options down the road. Now, as you can see, what I did was just draw a simple square for a breaker. Now, it could be any other device that is utilized as the source for that circuit. And then from there, I drew a simple straight line going across the page. And from that, then I began drawing the different branches and or different sections of primary, so to speak, of where the circuit runs. Right now, of course, I try to do it as simply as possible. Simpler in this case that you draw the diagram, the better, and the much easier it is to interpret what you're looking at. So after drawing the simple one-line diagram, then I go one by one and I start labeling each of the devices as far as what they actually are. Either you can do it either starting from the beginning of the circuit towards the end, or work your way back from the tail end of that circuit all the way back to its source. It really doesn't matter. So continuing with our example, in this case, I have decided at the very tail end of the circuit, this to be an air switch. Prior to that, we're going to utilize a disconnect. Prior to that, we're going to use another air switch and another air switch. Now, for the different devices, you can utilize different symbols and different letters. I choose to make things simpler. If it's going to be an air switch, I use an A. If it's going to be a disconnect, I'm going to use a D. If it's going to be riser fuse, I use an R. If it's going to be a section fuse, I use an S. In any other devices that you may have, you can utilize different letters, different symbols, whatever you prefer, in order to make that distinction. Now, as far as the actual labeling of the device and whatever that device is called, different companies have different ways of labeling their devices. Some companies may utilize a numbering system that follows similar to the description of the actual subs and the breakers and down to the actual device. For example, your company may utilize a device such as a disconnect. Let me just go ahead and write D. And they may utilize a device, let's just say it's going to be sub number 1, 0, 1, followed by breaker number 2, followed by the 6th device down that circuit, right? So you utilize this numerical, some sort of labeling system as shown below. In this case, I'm just going to utilize different numbers at random, and I'm just going to put different numbers for these devices, just a brief example, just to give us a brief example. So for the air switch at the end, I'm going to utilize A1, 2, 3. Disconnect, I'm going to utilize 2, 3, 4. Air switch 3, 4, 5. And air switch 4, 5, 6. So now that we have all of our devices labeled as far as what we utilize in order to transfer the load out, what I like to do is write down and list going down the page as far as what circuit this current circuit can be transferred to. So example, let's just say this is circuit number 1. This is going to be possibly transferred out to circuit number 3. This can be transferred out to circuit number 6. This can be transferred out to circuit number 3. And this can be transferred out to circuit number 2. So once we know what circuits are available to transfer our current example, which I'll call circuit number 1, then I like to list down, do it almost in a numerical manner. Circuit number 1 can be transferred out to And then here, I list the different devices as far as what we drew in our diagram and what we currently have. So circuit number 1 in this case can be transferred. So when I list these devices, I'm going to go from the source towards the end. So in this case, circuit number 1 can be transferred out to circuit number 3. Plus, I'm also going to be utilizing the device right next to it, which is in this case is A456. It can be transferred out to circuit number 6, utilizing A345. Could be transferred out to circuit number 3 again, using D234. And finally, we could transfer it to circuit number 2, utilizing device A123. So now that we have our devices listed and what circuits can actually be transferred to, we can then figure out and begin the next process as far as analyzing the actual loads and trying to figure out what can actually be done and which ones we can actually utilize going forward.